Okay, we're going to talk about, this whole chapter is about circles. Today we're going to talk about a circle graph and percentages and degrees and things like that. If I wanted to find the value of x, we've probably seen different circle graphs before. But like if I was to survey everybody in here and ask you, what is your favorite ice cream flavor, right? So we might get some vanilla, we might get, I don't know, what's somebody's favorite ice cream flavor? Cookie dough, all right, there you go. So maybe 23% said cookie dough, maybe cookies and cream, maybe whatever it is, right? Everybody's gonna have a little bit different flavor, right? A little bit different idea. Well, to figure out what this leftover chunk is gonna be, what should this whole circle add up to be? 100%, right? Everybody surveyed is gonna be included in this answer. And so to get the missing piece, we would take 100 minus 23 minus 14 minus 34. Okay, what's that leave us? Okay. About 29%. Okay, the only thing different on the second one is that we have two chunks, and because they're both labeled with X, that means they're both the same percent, the same size. And so here I would take 100 minus 21 minus 32 minus 17. So that means we have 30 left over. And then because we have two of them, I have to divide it by 2, and that would give us 15. So each of these pieces would be 15% that's left over. Okay, so we're going to see some circle graphs like that today, talk about what they mean, and we're going to talk about some other things with them in addition to that. Okay, but first up, finding arc measures. Okay, the arc measure. Everything that we do each section in this chapter is dealing with circles, but different parts or different pieces of circles. We talked about some of the basic vocab or pieces of a circle with lines and rays and all kinds of things on Friday. They go through it. And now we're going to talk about some of the angles on the inside of a circle. So the first one is what we call a central angle of a circle. The central angle of a circle is an angle that is formed by two radii and has a vertex at the center of the circle. So if I was to draw a circle up here, and I tell you that C is the center of the circle, so therefore I would call it circle C, and that's what it's doing here. Circle C is the name of this circle. And then if this point right here is A, and this point right here is B, then we are forming an angle that's at the center, because C is the center of the circle, and we have an angle that's formed at the center. The arc that's between those two is what we call arc AB. And there's two different arcs that are formed here. The small one is what we call a minor arc. So from A to B here, I would label that as arc AB. But then I could go the opposite direction. I could start at A and go around the circle the opposite direction. And that arc is obviously bigger than the smaller one. It's bigger than 180 degrees. So a minor arc is going to be less than 180. A major arc is going to be greater than 180. Okay, so that's where we're going to tell the difference between these two. The way that I name the major arc here, if I put a point somewhere on this circle, let's call this point E right here, and I'm just making that up. I could put E anywhere on that circle, right? When I name the major arc, I have to use 3 letters to name my arc. And the symbol here is just a curve over the top of those letters. So 2 letters is going to tell us a minor or small arc. 3 letters tell us it's a bigger arc, or bigger than 180. Bigger than half the circle. Okay, so if I look down here, and I'm going to give you some examples of some measures here. Obviously, AB is a minor arc because it's less than 180. It's less than half a circle. So the minor arc here is arc AB. Okay, one of the things that I'm going to show you here, if I tell you that this angle on the inside at the center is 50 degrees, then the arc outside of that is also 50 degrees. The central angle and the arc that's making the same path will both be 50 degrees. And so here, and we wouldn't be able to tell that's 50 without measuring it and getting a tool out to measure it, a protractor. So I'm just going to come up with the number 50 right there. If I wanted to name the major arc, and it doesn't matter the order you go in. I could start at A and go through D and into B, or I could also go B, D, A. Same thing with this one here. Kind of like a segment. I can either call it AB or I can call it BA. Order doesn't matter. Typically, we probably use the alphabetical first, but this one could either be called AB or BA. This one could either be called ADB or BDA. But D does have to be in the middle because D is between the 2 endpoints. Okay, so you just got to make sure D is in the middle there. How many degrees do you think ADB is going to be? How many degrees in a circle? Anybody know?
360.
360, yep. Okay, so just take 360 minus 50. So ADB would be 310 degrees. Okay, so minor arcs are named with 2 letters. Those 2 letters must be the endpoints of the arc. And so in this case, we said it could either be AB or it could be BA. Either way is fine. But we know that it's less than 180 when it's only 2 letters. Okay, major arcs are labeled with 3 letters. And we just talked about that. ADB or BDA. Order doesn't necessarily matter there. Okay, inside this box, this is kind of what we just talked about. This kind of puts all the information together. The measure of a minor arc is also the measure of its central angle. So the measure of the angle on the inside of that circle at the center is also the measure of the arc outside of it. What we just said was an entire circle is 360 degrees every time. Full circle all the way around will always make 360. To come up with the measure of a major arc, we'll always take 360 minus the minor arc. Okay, and a semicircle, the prefix semi is half, okay? So we're talking about a half circle here, so 180 or 360 divided by 2 would be a semicircle. Okay, so we have a picture given to us here, and we're going to talk about the different pieces and the different arcs and how to find the angle measure or the arc measure of each one of these, okay? Today, we are not talking about length. Today, we are talking about degrees, okay? How many degrees would this be? So, RS. When I talk about RS, I'm going to start at R, and I'm going to go to S. The short way. You might say, well, which way do I go? Well, if I went from R to S this way, that would be bigger than 180, right? That'd be bigger than a half circle. So I got to go the short path, R to S. R to S is also the same as the angle on the inside of it. So 110 is my central angle, so RS is also 110. Okay, if I go the other direction, if I start at R, go through T, and end up at S, to get that measure, I'm going to take 360 minus 110. So that would be 250 degrees. Okay, these two numbers should add up to be 360. We're talking about two arcs that make a full circle. So when I put them together, they together make 360 degrees. Okay, and then you have to pay attention to the order of the letters. Okay, here S is in the middle. So I'm going to go R through S and finish at T. So I'm doing these in different colors so you can kind of see the path that we're taking. If I start at R, go through S and end at T, okay? Now here's the important piece. R to T goes right through P, and P is the center of the circle, right? So what does RT do to the circle? Splits it in half, right? And so we know that that piece is 180 degrees. It's half a circle. And we know that because this is the diameter. Diameter is what we talked about on Friday. Splits the circle in half. So the bottom half would be 180, the top half would be 180, if I asked you to name the top half. Okay, down here, we're just naming a major, a minor, and a semicircle, just so we can kind of get in the habit of naming these. And in some of these cases, there's more than one right answer. Okay, so there isn't necessarily like this is the only answer that I can have. We're looking first of all for let's do the minor arc first. Let's do the small one first. So I could do QT, I could do TS, I could do QR, or I could even do SR. Okay, I got a lot of different options here. I could also call it RQ. So QR and RQ are the same arc, okay? But that's less than 180. So we know it's a minor arc. I could do TQ. Okay? There's more than one right answer here. Okay? And so if it just simply says name a minor arc. Now if it says name a minor arc including the point T, I could either go TS or I could go TQ. So I could go either direction from point T. So you got a couple of different options there. Major arc. The biggest thing here is the major arc has to go past halfway. Where do I start? Doesn't really matter where you start. Okay? So if I started at R, I could go R and go all around to S. I got to go past halfway. We know that T is halfway. So when I name this, I'm going to go R, T, and stop at S. But I'm using three letters. R, T, S. Or I could do RQS. Okay, and here's what I'm going to tell you. Those two are the same arc. All I did was name them differently. Both of these arcs start at R and end at S, and they both go through these two letters. So when I name it, I don't need to use both. I can either go RQS or I can go RTS. In both instances, I'm going the same path and going and ending at the same points. Okay, so a couple of different ways to name the same arc in that case. Semicircle has to go across the circle and it has to go through here. Okay, so I could call RQT a semicircle, or I could say RST. Those are both semicircles because they're both 180. Those would be two different semicircles because this would be the bottom half, this one would be the top half. If you wanted to name it a different way, I could call RST TSR, and I could go the opposite direction. Does not matter what letter you start with, okay? Just has to go through the same. But I couldn't start with S because I don't have a diameter that starts at S, right? S doesn't go clear across the circle, there is no diameter. There's a radius here, but there's no diameter. Same thing for Q. I can't start at Q because there is no diameter that goes all the way across. So I either got to start with T or I got to start with R. So that's the one thing you got to be careful about with semicircle is, do we have a diameter, right? And if there's no diameter at those 2 points, we can't use it. Okay, the arc addition postulate, it kind of goes along with all the different postulates that we've talked about throughout the year. We talked about the segment addition postulate, and with the segment addition postulate, we said if I had a segment, I can take the small segment plus the bigger segment, and it would add up to equal the entire segment. We did that with angles too. If I had two small angles inside of a bigger angle, I could add up the two small angles and I could get the bigger angle. We could do the same thing for arcs. ABC is this whole thing right here, would be the sum of AB and BC. So if I added arc AB and arc BC together, it would add up to be arc ABC. Okay, so adding up two smaller arcs together makes the larger arc. A lot of this stuff today is kind of straightforward stuff, but just talking about naming and that kind of thing is really big today. Okay, this one goes back to finding the actual measure of each arc. What is the degree? All of our answers here are going to be in degrees when it says measured today. So GE. GE goes from G to E. And we know it has to be the minor arc because there's only two letters, right? So if I go from G to H, we know that one's 40 degrees because it's the same as the central angle. And H to E is 80 degrees. So if I put those two together, 40 plus 80 would be 120. Okay, math's not too bad. Hey, GEF, just follow the path of the letters. I'm going to start at E, I'm going to go through G, and I'm going to stop at F. GEF. And you might say, well, I went through H, how come we didn't say H? We don't need to say H. All we need is three letters. Okay? I could have also said GHF, and that would be the same arc, right? So you could name it either way. But I'm going to go 40 plus 80 plus, this one here would be 110. So 40 plus 80 plus 110. 230 degrees. Hey, and then finally, GF up here would be that arc right there. What would we do to get GF? Yeah, good. 360 is the total. We know the big arc is 230. So take the full circle minus the little piece that we had here. So that will leave us 130 degrees. Okay, when somebody makes a circle graph, and we're not going to actually make a circle graph right now because you would need some tools to make it. But within that circle, here, and this is kind of what we talked about at the very beginning of the lesson, we see the percentages, right? If I had a survey and I asked the teenagers here, would you rather meet a famous musician, athlete, actor, inventor, or some other person, okay? And see what the teenagers answered. And so these are the percentages of everything, okay? If we add up those percentages need to add up to be 100%. 100% of the people surveyed need to be included in our data, right? Kind of goes back to our probability stuff. But when I add up the number of degrees and I wanted to know what the measure of arc AC is going to be, how many degrees would a full circle make? 360, right? We've talked about that a couple times today. So if I wanted to find the measure of arc AC, I'm going to start at A, and I'm going to go around to C. Okay? So that represents two sections, right? It represents 8 plus 30%. So that is 38% of the circle. If I want to figure out how many degrees that little section needs to be, I would take 0.38, I'm going to change it to a decimal, and multiply it by the full circle. And you're not going to get always a nice whole number. It's nice when we get nice whole numbers, but that's not always going to be the case. Okay, and that's why probably making like a circle graph like this would be kind of difficult because we're dealing with decimals, and so it probably wouldn't be perfect if we were making it. But that little chunk of the circle would need to be about 136.8 or almost 137 degrees out of the full 360. If I wanted to do ACD, I'm going to start at A, I'm going to go through C, and I'm going to finish at D. So this would be 8 plus 30 plus 23. So that would be 61%. So I'm going to take 0.61 times 360. So that chunk of the circle would be about 219 degrees. Okay? And it should make sense because if I drew right across here, this would be halfway, and we've gone a little bit past halfway because we've gone A all the way over to D. So we're a little bit past halfway. 180 would be halfway, so 219 would be past that. Okay, what percent would EBD be? I'm going to start at E, I'm going to go through B, and I'm going to finish at D. So just make sure you're moving in the right direction. E through B, stop at D. Okay, the easiest way to get this would be to take 100 minus 17. At least that's what I would do. You could add up 8, 30, 23, and 17. Or sorry, 22, 8, 30, and 23, everything except for the 17. So you could add up those four sections, or you could just take 100 minus 17. And I think it would be easier to do it that way. So we're talking about 83% of the circle is covered. And so we're going to take 0.83 times 360. And we know there's 360 in a full circle, so this is almost 300 degrees. But it's a really big chunk of the circle, right? We're talking about 83% of the circle is covered there. Okay. And this part right here, we are talking a little bit about degrees, but we're doing what we call congruent circles. The congruent circle theorem says two circles are congruent if and only if they have the same radius. And how do I know they have the same radius? Well, in this case, BD and AC are a radius, but what do I notice on BC and AD? Yeah, they have the same line. They have the same marking, right? These two markings are the crucial piece. Because those two radii are the same, that means those two circles are the same size. If I have one circle that has a radius of 4 and another one that has a radius of 5, those circles will not be the same size, right? But if two circles both have a radius of 4, then those two circles will be the same size, okay, every time. The second theorem, in the same circle or in congruent circles, so in this case, if two arcs are congruent, so in this case, we know these two arcs are congruent. We know CB and DE have the same measure because they are both marked with the same marking. Then the central angle on the inside of them is also the same. Okay? So if I tell you that these are both 40 degrees, then the central angles are also both 40 degrees. I could also do that with two separate figures as well. If I draw a circle here and another circle here, it can either be on the same circle or it could be on two separate circles. If I tell you that those two arcs are the same, then that means the two central angles would be the same. So it could be the same circle or it could be two different circles. Okay, so here it says, tell whether the indicated arcs are congruent. Explain why or why not. Okay, RS and TU. Okay, do RS and TU. If I were to draw those two circles, do we know anything about the radius of those two circles? Not really, but the radius of the small circle is RQ, right? The radius of the big circle is RQ and TR put together. So do those two circles have the same size of radius? The small one would have RQ. The bigger one would have TQ. Those two radii are not the same. So if the radii are not the same, then we would say no. These two circles are different sizes. Okay. In this one here, do these two have the same radius? Yes. Okay. They have the same radius. Okay. So are these two circles congruent? If one circle has a radius of 4 and the other circle has a radius of 4, are those two circles the same size? Yes. Yeah. Right? Because they have the same radius, right? Here, do these two have the same radius? No. One is RQ, one is TQ. TQ is longer than RQ, right? These two circles are not the same size. So they do not have congruent arcs. Okay? In this case, we would say they have same radius, or the radius is congruent. So we would say yes, that UV and YZ are going to be congruent. We don't know the length of it, but we know they're congruent. Okay, and what I want you to understand here is we're talking about length here. We don't know the actual length, but we just want to know, are those lengths the same? We won't talk about length for a little bit. Okay, we're not necessarily talking about the measure, we're talking about the length of the arcs here. Okay, down here. Are CD and EF congruent? What is the measure of the angle on the inside of both of those arcs? 80. So if they have the same angle measure on the inside, that means these two are congruent. Okay? So here we would say yes. They both have a central angle equal to 80 degrees. Okay, on the last one here, are these two circles the same size? Why not, Cora? Radiuses are different. So here we would say no. Radius is different length. Okay, so that's the key. When these two here are talking about, these are on the same circle, right? So the radius of this circle is the same for both of those markings, right? FB and FB are the same radius because it's the same piece. So when it's only one circle, that's a little bit easier. When they're two separate circles, are the two radii the same on the two separate circles? If they're the same, then all the markings should be the same. Okay, that's what you have to pay attention to. All right, 10.2 is what we got today. 10.2 should